Hello everyone, welcome to the tutorial series of Pine Language Quantitative Trading Practice. Today we will learn about the use and concept of functions in the Pine language. Let's open the website of Pine Language Introductory Tutorial of FMZ Quant. Then we go to the chapter of functions. Pine language functions are divided into custom functions and built-in functions. Generally, we learn the former one first. The following rules applied to custom functions in the Pine language. First and foremost, all functions are defined in global scope of the script. A function cannot be declared within another function, or it will report errors. Second, functions are not allowed to call themselves in their own code. That is, we may have recursive operations when writing strategies in other languages, but it is not feasible in the Pine language. Third, in principle, all Pine language built-in drawing functions such as bar color, fill, hline, plot, plot bar, plot candle. All of them cannot be called in custom functions. Last but not least, functions can be written as single line or multiple lines. The return value of the last statement is the return value of the current function, which can be returned in tuple form. And we have also used the custom functions for many times in our previous tutorials, such as those designed as a single line. Bar is up equals to or more than, close more than open. We use this one to judge whether the current bar is a positive line when the function returns. And we have also written the last line. Sum length is the return value of the function in the while loop structure, and while is the last line of the entire sum function. That is, the return value of while is returned as the return value of the sum function. That is, the function sum returns to the average value. Besides, the custom function also returns to a value in the form of a tuple. For example, the custom functions returns to a fast line or slow line. Here, fast, slow. We can use the brackets, and here we can get two lines, EMA1, EMA10, and EMA20. One is the fast line, the other is the slow line. So this is the custom functions return to a return value in the form of a tuple. Usually, in the process of writing strategies, we use the built-in functions, most which can be easily found in the in our FMZ Pine script document. Here we can click it and find it in our platform. Here. Classification of built-in functions in the Pine language, such as string process function, str series. We can find them in the contents also. The color value processing function, color series, and such as color new to create a color value and assign to it color RGB to adjust the color value. Actually, setting the color value is a hexadecimal string. Of course, we can adjust the color according to the specific tonary color settings. As we all know, the setting range from 0 to 255 is the red tones, but it may also be blue tones or green tones. And finally, there is the color transparency settings. In addition, there is the function input series. We have learned before, such as input source, input string, input int, and so on. Indicator calculation functions such as TA series we use most. There are calculations of various averages, standard deviations, and Bollinger Bands, all of which are function TA series. And there is the function plot series. We have used for many times, such as drawing of charts, shapes, characteristics, k-lines, etc. Next one, array handling function, array series. As for the trading related functions of the strategy series, we can use them to set the details of the transaction. For example, trading according to the pyramid to add positions, what the maximum number of times it allows to add, what its default order volume is, and what the default order type is, and whether the drawing is on the main chart or on the subchart, and so on. Next, math operations related functions, math series. For example, calculating the absolute value of a value, use random numbers, rounding up, rounding down, trigonometric functions, etc. Other functions that are not classified to a series, time handling, non-plot series, drawing functions, request series functions, type handling functions, etc. So that's all for the built-in functions classification. We can search them by Ctrl plus F in the API document page. The strategy series of functions are functions that we often use in the design of strategies. And these functions are closely related to the execution of trading operations. When the strategy is running, it is responsible for placing orders and other operations specifically. So let's learn the strategy entry function first. Strategy entry function is a more important function when we write a strategy to place an order. Several important parameters for the function are ID, direction, quantity, when, etc. Parameters. As for parameters, let's discuss them one by one. The first one, ID. This can be understood as giving a name to a trading position for referencing. This ID can be referenced to cancel, modify orders, and close positions. And direction. If the direction of the order is long or buy, passing the built-in variable strategy long, and if you want to go short or sell them, passing the variable strategy short. Quantity. This is specify the amount of orders to be placed. If this parameter is not passed, the default amount of orders will be used. As for the when parameter, its execution condition in the global scope. We can specify this parameter to control whether this current order operation is triggered or not. That is, only when the condition when it's true, the function strategy entry will execute. Of course, we can assign an expression or a function call to it. The limit parameter is specifying the order limit price when the parameter limit is not specified. The order is a market order. And if limit is specified, it will be listed at the specified fixed price. The last one, stop parameter, is a little complicated. It's the stop loss price we set. For example, when we buy, set the limit is pending at a low price and waiting for a deal. We use this stop price to say that we wait for the price to rise to a certain level and execute the deal. If strategy entry is a buy order, it can be interpreted as the buy may close the position. That is, wait for the price to be high enough to buy to close the position. It can be simply understood that if strategy entry is a go long buy operation, after setting the stop parameter, it will buy when the price rises to a certain level. That is, we set a price by expectation and then do the buy operation. The specific execution details of the strategy entry function are controlled by the parameter settings when the strategy function is called, and can also be controlled by the Python language trade class library template arguments. We can click this address directly. It's arguments of Python language trade class library setting control. Python language trade class library template arguments control more details of the transaction. You can check the link documentation for details here. And let's focus on the parameting default quantity value parameters in the strategy function. Here we use the following code for tests. We can copy it directly with the backtest information and save it. Here we choose Python language here. Just pass it and don't forget to save it. Oh, we can name it as time 1 here. Save it. Here is the backtest information. Let's look at the strategy code. First, we set the trading details of the strategy with the number of pyramid additions. That is, the maximum number of trading in one direction is 3, which means that it will not go on the 4th time to place an order. It just acts as a change. Then we set the default order size to 0.1 here. That is when we call strategy entry without specifying the order size. The order will be placed according to the default order size. And we specify all the charts drawn on the main chart. Here we declare a global variable EMA10. Then we use the function TAEMA to calculate the indicator. We calculate the closing price and an average with a period of 10. Then we write the custom function to check if an order has been placed for a tag. Here we pass long 1 into the function. So it will check whether the tag of the current long 1 . So it will check whether the tag of the current long one already has an admission order. If so, it will return to true. If not, it will return to false. Why do we want to write this custom function? Because it is related to our test scenario where we want to place an order for this position with a tag long1, and then place orders for long2, long3, and long4. That is, place orders for admissions with 4 different tags. 4 different tag IDs. If we write the function strategy in the global scope, it will place orders constantly, and the opportunity for the following long 2, long 3, and long 4 to place an order will be occupied because we have set the number of parameters to 3 of parameter position addition here to 3. It can only add up to 3 positions, including the first order. But if we don't set this way, it won't achieve such a test result. So we set such a custom function each time the execution of strategy entry to determine whether the label long1 has been treated. If yes, then return the return value of the function call. If the return value is true, it proves that the order has been placed. If it's false, do not execute this line of code. Strategy entry long1, strategy long. That is, if long1 has already been treated, the entry of the label long1 will not be performed anymore. The same as the following long2, long3, and long4. Let them make their entries in turn, and then we will see which orders to close and which ones don't. For example, in the example of long 3, we executed the order 0 to 0.2 and then the order 0.3, both of them with the same label of long 3. We executed the order 0.2 and then the order 0.3, both. The following order operation actually did not reorder, but only modified the previous line of long 3. The amount of orders placed from 0.2 to 0.3, and then executed the last k-line bar as the order price, and then specify the order price as the limit order. At the same time, the order quantity was modified from 0.2 to 0.3. As for the tag long2, which we set the parameter when to let it place an order, only when the closing price is greater than EMA10. Finally, we set the label long4 and observe whether it will be treated if the previous 3 are treated. Then we set the parameter to add 3 positions to the maximum, and the fourth will not be ordered. Then we draw this EMA10 on the chart. The first time we place an order without specifying the amount of orders to be placed. So we click backtest to see if we will place the order according to the default order amount. Here in the log message column, we can see that the first line of log input is the printing of account information, balance for money, stock for underlying B, and the second line of log output shows that the price per jump is 0.1. That is the current setting of the parameter species, each price change of 0.1. This price change is related to the pricing currency accuracy we set. Pricing currency accuracy refers to the price of the plate. It is accurate to the first few decimal places. For example, here we set it to 1. That means that when placing an order, it is accurate to the first decimal place if is set to 0. It is accurate to the single digit. The price per jump is determined based on the precision we set for placing orders. If we set the price in currency accuracy here to 0, and we click backtest again, and here in the log message column, we can see that the price per jump becomes 1 here, which is related to the pricing accuracy. If it's set to 0, it is accurate to the single digit. If we want to place an order every 5 jumps, we can adjust the order slippage points. We can adjust the order slippage points and set it to 5 here. Then we look at the specific implementation of the function strategy entry function. We can see that it triggers 3 entry order operations. The first is the label long1 entry. Entry price of 19252, entry order volume of 0.1 in the corresponding code page. In the corresponding code page, we can see that the first entry tag is long1. We did not specify the amount of order placed, so it placed the order at the default of 0.1. We can see 0.1 in this position of entry. And long1 is also marked. The second entry is long4. Let's go back to the code page. The label long4, we specify the amount of order is 0.2 without specifying the limit and parameters when. Then it's entered as a market order. So we can see in the log message column, the second entry is long4 here. Then the third entry is long2. Let's go back to the code page. The label long2 has set a condition. When close, that entry is made only when the price is greater than EMA 10. We can see the entry in the of long2 clearly on the chart when the K-line closing price is above the red EMA. It makes an entry trade immediately. At the beginning, both long1 and long4 are market orders. Both of them are entered when the strategy first starts to run. It only starts to enter when long2 meets the win condition, that is, when close is greater than EMA 10, and there is long3 left, that is, we have made a pending order so that its pending price is the closing price of the last K-line bar. That is, we do not let it due immediately since we set the pyramiding parameter equals to 3 here. The subsequent long 3 will not be traded again. And we can see in the status column, the long 3 here is in the schedule orders. Long 3 is always waiting for traded here. So when will long 3 make a trade? Unless one of the labels of the previous entry long 1, long 4, and long 2 is closed out. And this time, if long 3 meets the conditions of pending order price, it will make an entry. Otherwise, it is always in the pending order state. The function strategy series, we haven't demonstrated the stop function. We won't go into much details here, but if you are interested, you can test it out for yourself. On the basis of our publicly available strategy, stop is a stop price. The buy order is placed or stop loss on the short position, and when the price of the short position keeps rising, the short position is a losing state. We can set the stop to a higher price to buy it when the price reaches this position, rather than buy it immediately, equivalent to planned commission. Here, in the Python language, we name it as stop. So that's all for today's lesson. If you think our video tutorials useful, don't forget to like, follow, and repost. Thank you all and see you in the next video.